So blockchain is really a group of technologies that were brought together in order to enable the global transfer of money and information in a truly distributed fashion. And with that are coming a lot of other changes, right? So this is really a technology enabler. And we talked about Bitcoin really being the one that sewed all these things together and launched. It's still a very popular cryptocurrency. And we did start about talking about cryptocurrency. This session we're going to get a little bit further, and we're going to be able to talk about how blockchain may affect business and how we can talk about blockchain for business and go through some examples. So we're on key attributes of public blockchains right now. And again, we talked about truly distributed, runs on thousands of nodes across the world, decentralized, open, borderless, neutral. A lot of the key attributes, again, that, as I mentioned earlier, potentially related to social change, significant change in how our financial systems operate and how control of our financial systems work due to all these technical attributes. Compelling use cases, okay, we talked about that before. Bitcoin, Ethereum, others used as a currency, but then again some of the more blockchain for business use cases around healthcare, identity management, crowdfunding, supply chain management, and so forth. So we talked about some of the technology concepts, hashing versus encryption. So remember, hashing is described in a lot of cases as a digital signature where you take some amount of data, you run it through an algorithm, and you will always get a fixed output. Encryption, on the other hand, takes your data, ingests it, scrambles it, and you will get a variable length output. With encryption, you can go back, you can send that to someone, you can use the key, and you can decrypt it, and they can read that message. With hashing, it's one way. No one can ever take the hash that you send to them and decrypt it and figure out what was used to create the hash. So it's truly for fingerprinting and creating signatures. We talked about reaching consensus. The most common and most proven consensus mechanisms today are proof of work, or is proof of work. And that's one where we talked about where we have some computers that are called miners, and these miners solve a mathematical problem. Once that problem is solved, they share the solution with the rest of the network. The problem is very difficult to solve, but it's very easy to validate. And so they share it back with the network. A number of other computers validate that that work was done correctly, and then they will add that block to the blockchain. Some of these others are attempts to get away from the electricity consumption associated with proof of work and to try to find other reliable methods of reaching consensus while maintaining the integrity of the blockchain. And again, one of those key attributes of immutability, which means unchangeability. Okay, so here's where we're going to start today. Blockchain, both public and private, take advantage of what are called wallets. It's a little bit of a misnomer. They probably really should have called these key stores or keychains or something else. Your wallet in a blockchain space does not actually hold or contain any of the value that you hold, right? So if I have 10,000 Bitcoin, I have a Bitcoin wallet. Those Bitcoin are actually stored on the Bitcoin blockchain in transactions. But what my wallet has is the address of where those are stored, and it has my public and private key. And so when I want to access my Bitcoin, I need to use my wallet and send a transaction to the Bitcoin network. And I do that by sending my account address, or in some cases it's called accounts, sometimes some cases they're just addresses. So I'm going to send my address. I'm going to say how much Bitcoin I want to transfer. I'm going to say the address I want to transfer it to, and then I'm going to sign that transaction using my private key. But I'm also going to send my public key with the transaction. And what happens when that gets to the network, there is a certain amount of reading of that transaction that can be done, or validation, let's call it, of that transaction that's done using the public key. And the validation that's done ensures that the content of the transaction was not changed between the time I sent it and the time it was received on the network. So no man-in-the-middle attacks can occur. And it also validates that the private key that was used to sign the transaction is associated with the public key pair that was sent with it. Okay? So that's what's important about your wallet. It doesn't actually have the coin in it, but it's your only access to the coin or to the value. They are the most important part of your blockchain transactions, again, whether public or private, and we'll talk about wallet security and why that's important for business and how to secure your wallets. And then also from a individual perspective, if you choose to participate in the cryptocurrency environment and trade currencies, be aware of how important your wallet is. In any blockchain scenario, there is no one to help you recover your wallet. So there's no like password reset email and they send you a new copy of your private key. There's no phone number to call and say, hey, I lost my file on my computer that had my private and public key and my address. So that any value you had associated with those addresses and those keys is unrecoverable. The keys themselves are unrecoverable. So it is essential that you do your best stewardship of your passcodes, your private key, your public key, and your addresses. And again, in business, we'll touch on it later. That's where you want to make sure you're using dual signature wallets. We'll talk about where two people have to sign, and that you want to make sure you keep those in a key store. There are a couple different types of wallets I wanted to mention here. So there are online wallets, nearline or hardware wallets, and then offline paper wallets. So believe it or not, this whole thing is all technology, all this crypto and signing and signaturing and encrypting. The most secure thing is a paper wallet that you print off off your printer. So you can go to a website, you can disconnect yourself from the network, you can use the Java app to create your wallet, save your wallet, print your wallet, and then delete that and then reconnect to the network. That is actually the securest way to save your content. All right, so this is a hands-on class or hands-on session. So I'm going to walk through creating a wallet on the Ethereum blockchain, okay? So the first thing we're going to do is we're going to navigate to this website, myetherwallet.com, and we're going to use this function called generate a wallet. We're going to enter a password, and again, you want to save this in a secure place. We're going to enter it into the password. I always enter it offline somewhere first and then copy, cut, and paste so I know I don't mess it up. And then we're going to save the key store file to a location off the network. So I'm just going to walk through these screenshots first because these screenshots are the same thing we're going to do. So you can see I'm at myetherwallet.com here, and I'm in the new wallet tab, and this is where it's asking for my password. And then what will happen is it will create a file for me, a JSON file, and then I can download that JSON file and save it on my computer. And I can also print a paper wallet if I want to. And then we can unlock the wallet, and I will go through a step of doing that. And then we can use, and then we can view our wallet, and you can view the address and encryption key. So the address is what you're going to need if someone needs to send you some content. And a blockchain for business perspective, addresses will be used to send information to different businesses or to save information on a supply chain network, for example. And these are what addresses look like in the Ethereum network. So there's a QR code style and then there's just the long address itself. And then here's my private key. And like I said, the private key you want to keep secure because, again, if someone gets the other thing is someone gets a hold of your private key and your public key, they can take your money. Okay, so here's the first step. You'll see that I'm at myetherwallet.com. The steps are similar for Bitcoin. You can go out and you can find a Bitcoin wallet software creator. This happens to be a software creator for Ethereum. So I'm going to enter a password. Let's call this Lunch and Learn. All right. So we're going to create a wallet. So it created it. It's very quick. It uses, again, an algorithm to go out and generate an address, and then it's going to associate my passphrase with the private key and public key with that address. And now I can download this JSON file. And we can open the JSON file. You guys are all techies, so we'll see what that looks like. So simple JSON file, key value pairs. So you'll see that there's the ID, that's my wallet ID. Here's the address on the Ethereum blockchain that's associated with that wallet. And then some other content. I don't know if it's actually going to say the name of my private key or not. The salt. So that was my passphrase that I added to the encryption mechanism. Okay. So we have that. So we have our key downloaded. Okay, and here are the same warnings that I just shared. Don't lose it. It cannot be recovered. Don't share it. Your funds will be stolen, and make a backup. I understand and continue. There's my private key, so I can save that if I need to. It's in that JSON file. If I wanted to print a paper wallet, I could do that. I could print this and then be disconnected from the network and then only use this when I want to transfer some funds. Go back here. Save your address. Okay, now unlock your wallet to see your address. These are a number of ways you can unlock your wallet. I know a lot of this is not going to make sense without going into this a lot deeper. I'm going to unlock the wallet using my keystore JSON file, okay, which I just saved on my PC. So it's going to ask me to find it. Okay. And so it says it's read the file. Now I have to enter my passphrase. There we go. So my wallet is now unlocked. And if I want to send some money to this address, I can do that, and we will do that in another step in the session, hands-on session. So we created a wallet. As I've said, again, this is going to be in any blockchain scenario. There is going to be some form of wallet or wallet provider that handles these critical pieces of information that are used to interact with the blockchain. Some additional concepts. So there's a concept in blockchains called smart contracts. Smart contracts are programming languages that can be used on the blockchain. Each blockchain has its own unique programming language. Again, this presentation is focused primarily on Ethereum, which is one of the top blockchains in the space, both for public and private blockchain. And their programming language is called Solidity. Excuse me. It's considered to be a Turing-complete language, and the reason they make that distinction is that means it's basically a full-bodied language. It's got if, thens, elses, loops, and all that kind of stuff. The Bitcoin network, on the other hand, does not have a Turing-complete language. It has a very limited set of instructions. And that's what helped with the incentive for Ethereum and some of the other networks to be developed is to deal with some of the shortcomings that in the blockchain on the Bitcoin network. Although Bitcoin is still extremely popular and it is the top blockchain network and it is used for a lot of blockchain for business solutions as well. So Solidity in this case, it's a JavaScript type language, pretty straightforward. And what you do is you write your program, you compile it, you publish it to an address on the blockchain, and then you have procedures and methods that you can call from an application to then perform work on the blockchain. For example, a blockchain for business scenario would be something like land titles. So today, I'm not sure all has had an opportunity to purchase a house or sell a house. there's a whole titling and title insurance process associated with that, where the county records are searched, they look for clouds on the title, you get insurance and all that stuff associated with that. So a blockchain for business scenario would be to use the blockchain to store those documents and records of those documents so that there will be less chance of fraud, and you could use a smart contract then to handle the purchase or sale of a house and manage that transaction and eliminate some of the intermediaries that exist today, the county recorder's office, potentially significantly reduce title insurance costs because everything would be visible and certified on the blockchain, and the ability to do direct peer-to-peer funds transfer if you wanted to on the blockchain. And so smart contracts are what would drive that. So just like the work we do here to do development for the business and put together a business case and walk through the process flow, there are people out there doing that for title insurance, for example, and writing those programs. And you would access them by having the right wallet and the ability to connect to it. This is a very simple example of a smart contract on the Ethereum network. This is basically a hello world for blockchain. It starts off saying it's a Solidity program. This particular contract is just called Inbox, and all it does is send a message. All right, so another important concept to talk about are coins versus tokens. So when you hear about Bitcoin, for instance, Bitcoin is kind of unique because the coin and the blockchain have the same name, Bitcoin. Ethereum, on the other hand, the name of the blockchain is Ethereum. The name of the coin is Ether, or ETH. All of the coins, whenever you see one that's a coin, that means they've written and published their own blockchain. So there's one site that has a listing of all of the coins, and there's over 1,200 different blockchains out there. So you might hear of Ripple, which is a blockchain that was developed to help financial institutions transfer money. There's one called IOTA, which is particularly focused on IoT. There's Stellar, I'm not sure what that one is, and a couple others that are kind of gaining in popularity. So those will have their own coin. And when they launch those, it's called an ICO, an initial coin offering, and you can invest in those just like you would invest in a stock. Tokens, on the other hand, typically sit on top of a blockchain. And again, Ethereum's a great example of this, where Ethereum has its underlying coin, Ether or ETH, which is used to fuel transactions in the network. And then you can write smart contracts on top of the Ethereum network and issue your own token without having to go through all the effort of creating your own blockchain. And so tokens are an important concept for a couple of reasons. There's a couple of varieties of tokens. There are tokens called fungible tokens and tokens called non-fungible tokens. Fungible tokens are interchangeable. They're all identical. So it's like I've got 2 quarters in my pocket. Each quarter is worth 25 cents. They're exchangeable. They're identical. Or $2 bills. Any of us could put a dollar bill on the table. You know, other than serial number and all the other stuff, just, you know, they're essentially identical and they have the same value. Each token has the same value. Fungible tokens are also divisible. That's one of the things you'll see in the cryptocurrency environments is an Ether, for example, is in the middle of the value of Ethereum. It can be divided by hundreds of thousands or millions, and it can go the other direction into point millions. And they have different names at those different levels in the hierarchy. You can do that with fungible tokens, right? So I can give you, let's say my token is $1. I can divide that, and I can give Cheryl 1/10 of $1 if I want to. So I can give 1/10 of my token and still keep 0.9 of my token, okay? Non-fungible tokens, on the other hand, are not divisible. They're unique. And the reason that non-fungible tokens have a lot of value is for the uniqueness. You can almost think, I looked at a non-fungible token and I almost consider it a unique record or unique table, or it's like a person. A non-fungible token is like a person, right? We all have unique attributes that really can't be exchanged with anyone else. One of the first very popular successful solutions on the Ethereum network is a game called CryptoKitties. And so what it is it uses non-fungible tokens, and you can buy a cat from someone. So they started off with a litter of kittens, and you can buy a unique cat from one person, you buy a cat from another person, you breed the cats, and now you get a new litter of cats, right? Well, each one of those is a new non-fungible token on that network that can be exchanged and traded. It has its own unique set of attributes, and it can have value different than all of the other tokens in the network. So you can see how that would be valuable for blockchain, for business, when we sell our vehicle. All right, so now we're going to walk to the next step of the hands-on blockchain part. I'm going to do the same thing. I'm going to walk through the screen captures I already have in the slides, and then we'll do it interactively. This one is a little more complicated than the last one. This is an example of doing a certification on the blockchain. So I talked about land titles, we talked about cars. One of the other very simple use cases that I've been thinking about a little bit is certifications, right? We all get professional certifications, Java class or blockchain class or whatever. So there's an opportunity to save this content onto the blockchain, and then it's accessible globally. It's certified because it was saved on the blockchain by the certifier. So in this case, the example is this method certifies that blank, an individual, attended and successfully completed the hands-on blockchain session at the Atlanta ISACA Geek Week 2018 as witnessed by Knaebel. So like I said before, I did this presentation at that conference, and so we walked through that. Someone gave me their name, and we saved their name to the blockchain. What we're going to do here, we created the wallet. When you send a transaction to the blockchain, you can either send money, you can send money and content, or you can just send content, right? You still have to pay to send the content, so you'll still be charged a transaction fee, but I don't necessarily have to send $1 worth of value to Jim to send a message and have it saved on the blockchain. These are the steps we're going to go through. Ethereum expects the payload to be in hex, so that takes an extra step. It doesn't take an extra step programmatically, but when I'm doing it here, just using publicly available websites and solutions, we're going to have to go through an extra step. You have to have an open account with enough Ether to pay the transaction fees. We're going to enter the transaction information, click on the transaction to view it in the blockchain browser, and then once this transaction is successful, we'll see the data on the blockchain. So here's the example. What we did was we took that message, I plugged it into an ASCII to hex converter. You see the output array on the bottom. I copied that output array into a transaction. In this case, this interface I'm using is called MetaMask. It's one of the common interfaces that you can it's a browser plugin. And so I copied that content into the optional data section down at the bottom. I went ahead and processed that transaction or submitted it to the network by logging in and providing my public and private key for the account. And then that went ahead and, in this case, you see it processed on the network in about 16 seconds, right there in the timestamp. So that's, again, an attribute that you get for free, basically, on the blockchain, as you'll see exactly when this transaction happened. That can never be changed. So again, part of that immutability and trust that can be created on the blockchain when you're talking about transferring data among partners on an open network. And then the actual data payload itself is down here at the bottom. And you'll see it's in the hex format that I copied into the text box. And then in this case, this website allows you to click on this bottom thing that says view as ASCII, and we're going to do that, and you'll see that this message certifies that blank attended the conference. I'm going to go ahead and go through the slides. I'm going to wait for MetaMask to connect and we'll talk about some more important concepts. This message that I showed here is a very small message. Particularly the Bitcoin network, but also the other blockchains, are not a good scenario for large pieces of content, right? So this is probably about as big, or maybe something 2 or 3 times this ASCII text, is the reasonable amount of data to save to the blockchain. So you have to pay for the size of your message, the time it takes to process is associated with the size of the message, but the biggest thing is really the cost, and the size of the blocks and the way they're processed does not lend themselves to large data sets. So in order to address that problem, what people have started doing is what I've kind of loosely categorized as data proximity, and there's a few ways to handle data that needs to be associated with a blockchain transaction. One of those is to save it on the blockchain, okay? And that's the example I did. I had a very small ASCII content. I saved it right to the blockchain. Anybody can go look at it and whenever they want to. There's a concept of a side chain. Side chains are used for micro transactions. This is a little off topic, a little deeper, but when you look at the blockchain, or the Bitcoin network in particular, it takes 10 minutes to process a transaction, and it takes really an hour for that transaction to be considered immutable, because you really want to have 6 blocks worth of depth, and since each block takes 10 minutes, that means it takes an hour. The Bitcoin network is also relatively expensive. It can be up to $5 for a single transaction, right? So that's not going to be a great use case for buying an ice cream or a pack of gum or something like that. So what has been developed are called side chains. So what a side chain will do is say, I'm going to lock your account on the Bitcoin network that has $10,000 in it, and I'm going to take that $10,000 off the network, and then we're going to trade back and forth for a week. So let's say we're a company, and cars is not a great example because obviously the amount I gave was too small, but so let's say we're going to trade back and forth with a retailer, for example. And so the retailer has this amount of money, and they're going to buy and sell. And then once an hour, once a week, once a day, they're going to say, okay, I'm going to go back now and unanchor this to the blockchain. I'm going to write this as one record to the blockchain, and then I'm going to settle that, and then I'm going to lock the account again and go again, okay? So it's a way to enable what are called microtransactions to occur on a slow network. The real point here for blockchain for business are the 2 bottom ones, which are anchored to the chain and completely off the chain, which then doesn't really become a blockchain solution, right? Anchored to the chain, this is where hashing and encryption come in again. So you can have a content, let's say a car title, for instance, and you take an image of the car title and you run that through a hashing mechanism to get a fingerprint for that car title. And then what you do is you save that fingerprint to the Ethereum network or to the Bitcoin network, along with the address to the actual document. So then someone can go look at the network, they can pull the address, they can then pull that document, they can run it through the same algorithm, get the same fingerprint, and go, yes, this is the valid document. So that's how, from a blockchain for business perspective, people are working around the limitation on the data size on the blockchain networks. The last one, like I said, is off-chain, which is really nothing more than a database. And again, maybe you put some kind of pointer, not as sophisticated a pointer as some of these anchor to the chain mechanisms, and you say this is this record in the database. But you're giving up a lot of security and immutability in that scenario. So here are the key takeaways. So blockchain enables disintermediation. I've talked about that many times. It will be disruptive. It is still in its infancy. Look for lots of use cases, again, that take advantage of borderless, fully distributed, censorship resistant, the ability to program money, accessible, visible, all those types of attributes of systems that we have today just don't have those characteristics. They come close in a lot of cases, but they don't have all those characteristics together. So the reason this is important for that audience as well as for us is there is a so significant potential to disrupt business. So we've talked in the past about being innovative, and everybody brings up Airbnb and Uber and all these other companies. Imagine the next step of Uber without the control of Uber, Airbnb without the control of Airbnb, and the multi-billion-dollar company that's become. So the advice is for senior leadership to look at this technology, to understand its capacity for disruption, and to look at your business and go, are there places in our business where the only value we add is essentially moving a paper from the left side of the table to the right side of the table? And we are nothing more than an intermediary that processes a step based on our current position, essentially as a middleman in some business process. And to identify those and then prioritize them in terms of which of those would most likely be easily automated and or could a direct peer-to-peer relationship could handle that transaction if the right technology was behind it, and those are ripe for disruption. And then you need to make a decision, are we going to be the disruptor or are we going to be disrupted? So very key, there's really a significant underlying technological change going on here. Next one is to be diligent about partner selection. Again, I'm not trying to age discriminate here, but I'm going to do it anyway, I guess. All of the stuff I have been involved in so far, these are very young participants, and there's a lot of irrational exuberance. I've seen a lot of I've seen a lot of very basic mistakes made already. I've talked to guys that are like, we had $10,000 in Ether on our full node that we were using to process transactions, and someone hacked our node and stole it. And I'm like, duh. You just don't do stuff like that. That's just, kind of basic IT 101. You don't put your database and your app server and, and all your keys and your passwords on a publicly accessible internet server. So those are the kind of things just to be aware of as we look for partners in this space, to make sure there's a combination of disciplined SDLC practices and processes that can be validated, and that there's control and organization and a strong sense of security and cybersecurity, and matched with an excited development workforce that's eager to make a difference. Understanding the ecosystem, there is a very large ecosystem of companion and supporting products, and I've got this in some of the slides. I will distribute the slides this time so you guys can look at it. There's a lot of links in there. So there are the core networks, but that's just one little tiny slice of what the ecosystem looks like. So there are new browsers being developed that are particularly well suited for managing blockchain transactions. There's a whole concept of IPFS, Internet File Service, where we talked about data being stored on the chain or being stored off the chain or anchored to the chain. A lot of these distributed networks are taking advantage of IPFS, which takes that data, creates the signature for it, splits your file up into umpteen number little chunks, encrypts them all, and stores 5K on my PC and 10K on Sun's and 50K somewhere on someone's Amazon solution. And when it's needed, it goes, finds all those pieces, reassembles it, and presents it to the user. There are a few different solutions like that. There are a lot of things now that payment can be automatic and instantaneous without going through a payment system to now more successfully take advantage of idle resources. So there's a blockchain-based solution out there that's targeted at idle processing capacity. So the laptop or desktop that you have, it's sitting at home right now. Perhaps you left it on and it's just sitting there eating, not only sitting, potentially eating electricity, even though probably not very much, but it's not doing anything. Well, you could get paid for leaving it on during the day and having that processing capacity made available to you and get paid for that in Ether tokens or Bitcoin tokens or something else by participating in these different solutions that are out there in the ecosystem. Other things to understand when making a selection for Bitcoin for Business, you need to understand whether a token is a better solution for us as a business than a coin. In other words, do we want to go out and really spin up our own coin? It's not, I haven't done it. It doesn't seem like it's all that hard. You can basically download a lot of the code from GitHub or wherever else and make some modifications and say, this is lease plan coin, right? This is LP coin. We could go create LP coin probably in a month if we put our heads together and looked at some stuff and launched it. Or is a token good enough? Should we just take advantage of an existing framework and then say, and we're just going to add our own LP token on top of that, and we're going to use the token for incentives and for value transfer, and the token can be exchanged on these. There are many exchanges out there, just like the New York Stock Exchange or whatever, or the currency exchanges you see in the airport, basically online exchanges. So you can exchange one token for another all day long with no issues. Public versus private versus consortium. Another consideration. So I've talked primarily about the public blockchain. I think I've mentioned before that Ethereum has what's called the Ethereum Alliance, the Ethereum Enterprise Alliance. They're very closely tied with Microsoft. You can go spin up an Ethereum, your own Ethereum blockchain in a matter of minutes on Azure. And that can be used as a private blockchain. So you could say, okay, we're going to create a blockchain on Azure. We're going to run X number of nodes. We're going to distribute that amongst our trading partners, and we're going to run our own private blockchain. So that would be a private using a public distribution. You could write your own. And then consortium. So a consortium is where, again, you might get together with an alliance, an association, and you run your blockchain, but you have someone else do the actual processing so that you kind of maintain that integrity. So they're starting to be developed networks of businesses that are providing horsepower to these, and so you get an extra level of security by doing that. It's called a consortium. You do have to look at, are your players trustworthy? There are a lot of cases. There's a lot of fraud in this environment, right? It's ripe for fraud. There's not a lot of identity who you're doing business with. What do you call that? It's anyway. There's a lot of opportunities for fraud. A lot of these coins, they actually call them shit coins. So people will just go launch a coin, try to raise a bunch of money, but the underlying white paper, that supported the launch of that coin really didn't have any true substance to it, and there was really no value in that business to invest in. So they do the initial offering, they cash in, and then they walk away. Tim said there was some news article about a company that bought a patent from Kodak and created a Kodak coin, and it followed the classic example of a shit coin. Okay. I'm sorry, I wouldn't normally cuss at work, but that literally is the name in the industry. They are literally called shit coins. We talked about on-chain versus off-chain, so make sure that you include that in your decision making, and what will be stored on the blockchain, and is it going to be visible? Do you want to, I showed that data payload. I used ASCII, to hex, but you could encrypt that and then put that on there. And then the only way to really look at it would be to give the individual who you want to show that to the decryption key, so they could decrypt it, or to do that yourself. How visible do you want your data to be? And then off-chain, if it's off-chain, will it be stored? Where are you going to store it? Cannot emphasize this enough, whether you're doing this just for fun, whether you're doing it for profit, You have to protect your wallet. I know I already said this. I'm going to say it again. A lot of these sites you go to create a wallet. I went to one, and I think I had to read 10 different pages worth of stuff that was more emphatic on each page about, remember, you lose this, don't call us. We are not going to help you. No, we cannot help you. So there is no way, zero. There is no way to recover. There is no one who can help you. Zero. So be very careful with your wallet. And this is where I started talking earlier about blockchain for business. You can lose everything also, right? So not only can you like misplace your keys or forget stuff and lose your content, if someone else gets a hold of it, it's a race. It is a race to see who gets to that account first and transfers that value out of that account somewhere else. You can't trace it because there are no person's names, no phone numbers, no addresses.
To that key, right?
You can see it to the key, but you don't know if the owner of that key lives in China or Bangladesh or down the street.
You just know it's gone.
You just know it's gone, and you know where it went. You know what address it's at, but you don't know who has the keys to that address and what they're going to do with it next. What they typically do,
Nothing.
Yeah.
No trace.
No trace. What they typically do, what I've seen typically done, is someone who steals a lot of Bitcoin is they instantly fire off hundreds of transactions and they just spread it and it spreads again and it spreads again to the point where it's traceable but unpractical. But it's all traceable. That's actually one of the great things about the blockchain is it's 100% auditable if you know who's associated with the address. It's that last link that's the part that's the missing link. Oh, the last thing is if you send it to the wrong place, it's gone. So, right? If I'm intending to send it to Jonah's address and I send it to some address in South Korea somewhere, there's no one for me to call and say, dude, that was a mistake. Can I have my money back? It's gone. So you have to be extremely, extremely careful.
So no email, where's the check?
No email, where's the check? No. Yeah, too funny.
Can you fat finger that key?
You could fat finger it. It's gone.
So it's like, I mean, does it not validate to the
No, there's nothing to validate.
Okay. Can there be a scenario where it can say it's a wrong key?
No.
No.
You could program that, I suppose, if you wanted to. As a developer, as a security for a business, you could say this is the key, but then you would want them to not have to type it in the first place. But no, if you change a 0 to a 3 by accident in this 26 character thing, it's gone. It's gone to 3 instead of 0. Yeah, it's crazy. So again, from a blockchain for business perspective, you can understand the criticality of the wallet, the passphrase, the private key, public key, where you're sending stuff. You really need to implement a 2 or 3 signatures, 3 or 5 signatures type solution so that you have different validators ensuring that the to address is correct, the from address is correct, the right keys are being used. There are solutions actually out there, different wallets that help facilitate that, or you might want to write your own additional checks in your business applications to ensure that these steps are done correctly. Because again, it's instant settlement and there's no way to go back. It's not like what we do today with our wires. Ensure that you follow your standards. And again, this really talks about your software development standards. Just like any other content that is sent to the blockchain, once you write your smart contract and compile it and publish it to the blockchain, it is not changeable. The only way to change your code is to kill that contract and replace it with a new contract, which now has a new address. You can have contracts talk to each other, which is very common. So there may be an option there to say, I've published this contract, it has an issue. I'm going to publish another contract that makes a call to that contract, or maybe you can leave yourself some I can't remember what you call it, some doors in your contracts that go to addresses that don't have another contract at them yet, where you could say, okay, if I have a problem in this contract, I know I can always publish another function over here and have this function call revert back, a hook, thank you very much. You could do a hook. But again, you really want to do your due diligence. You got to be careful because in most of these cases you're dealing with money too, right? So it's not like our programs where we are dealing with important things for our clients. Sometimes we deal with money, but in these cases, again, you could write a smart contract that's pointing to the wrong address and you're sending $1,000 a minute to the wrong address for some reason. There's usually a kill function that you can put in there so that the owner who published the contract can execute the kill function and ensure that any value that's still associated with that contract gets sent to a certain address. If you kill a contract that has value still associated with it, that's gone, just like deleting the private key. So if you have a contract, and the contracts have to have value associated with them because they have to spend money in order to pay for the processing power that they're using on the network. Consensus matters, I talked about that a little bit. Proof of work really is the proven consensus right now. The others are all in kind of a conceptual stage. From an IT background, I say run your own node. You don't have to run your own full node, but again, if you're going to develop, you're better off running your own full node. You can then turn on the RPC functions and call your node with your keys to then interact with the rest of the network. There are APIs out there. They're in the links. There are some providers who provide APIs that you can consume. But again, I say run your own node, back it up. I don't know why, but I guess that's just out of habit. Start small. Again, this is targeted toward business. Don't take your most critical business process, most critical, most complicated business process and say, we got to get this on blockchain by the end of the year. We're going to go out of business. You're not going to be successful anyway. So start with something small. 6, we're getting close. Understand your use case. Blockchain is the only tool to solve some problems, but it is not the tool to solve all problems. There is a lot of blockchain will toast your toast for you out there right now. Again, this kind of irrational exuberance. When you really start understanding the technology, you start understanding the use cases, they should start dropping off pretty quickly, but a lot of them aren't. Really, there's a lot of cases where just a great database will be a better solution. Other than that little piece of immutability you might need to tie something to the blockchain. And garbage in, garbage out. We talked about this. Jim and I had an email exchange after the last one, and we've talked about that a little bit here. Blockchain can only handle the part from once the data is in the network. If you look at a voting scenario, let's say that the government issued us all addresses to use on the Ethereum network to cast our votes in the upcoming election. Well, if someone else gets a hold of my key and my password and they go down to the voting office and they vote a different way than I intended to vote, there's nothing I can do about that. There's nothing blockchain could do about that, right? That's garbage in, garbage out, essentially. So that's it. I think we're about on time, right?
Yeah. 2 minutes over.
2 minutes? Okay, good. Yeah, so anyway, thoughts, questions? Good? Okay.
Very good. Thank you.
All right, you're welcome. Thank you. So I'm happy to answer questions. I'm happy to we can keep going down and peeling the onion back and getting more detail and do some sample solidity contracts and do some stuff with that if you guys want to mess around with that.